Hello, my name is Henry Reid, and today I'll be going through the COMP3004 coursework regarding the experiments of an SDN testbed. So I'm going to firstly start off with executing the Ansible script, which starts off as so. While that is running, I'm going to explain my Ansible script. So I have all the installation packages for the SDN testbed. So that would be Mininet, the switches for me to change the bandwidth on, iPerf for network tools, NetTools, curl, Apache for running the -js service, Epiphany browser for viewing that -js server, and some plugins to help me run that Epiphany browser. The Ansible script also includes copying the files from this directory into the home directory of the VM I'm working with, as well as installing -js /var/www/html. Go back and see the status. You can see that it failed. Oh, passed, sorry. Where you can see in the directory topo. Right. And if I go into topo, there is a bash script which goes into detail about creating the different video representations of the Big Bucks Bunny. So a 2400 bit rate, a 1200 bit rate, a 300 bit rate, as well as the creation of an MPD file, which merges all the bit rates representations of the video together. So if I do sudo gmod video compress, and then do video compress, this will create all the different representations. While that is doing that, I will go into video. That was just me testing if it was working earlier, where I can see if it's working or not. Okay, so it's working. Let's go into some background regarding the scenarios. So there are a total of 3 scenarios I've mentioned before: high, medium, and low. High is when the bandwidth of the switch 1 to switch 2 bottleneck is set to 100. For the medium scenario, that switch is set to 5, and then low, that is set to 1. As you can see from this Python script, you can see that this is the bottleneck link, and these are the hosts, where there are 2 hosts on switch 1, so that would be IoT traffic and the server running the -js service. And on the other side of the network at switch 3, you have the client who is retrieving the client server -js service, and also IoT traffic on the same one. This is still going. Okay, so you can see that it finished there. So if I go into cd/var/www.html, you can see that there are all the video representations. If I go back to the home page, I need to go into here. Topology, change that to 78, and then change that to 100. If I do sudo-e, which passes the network variables to the Mininet hosts, this should work. So it connects with the host, which is good news. We do H1, H2, H3, and H4. If I do H4, you can see that if I open up the Epiphany browser and then go on to here, and load the combined MPD file, you can see that it runs. as well as if I do a iperf-s and iperf-c 10.0.3, you will see the available bandwidth of that that link. Sorry, as you can see, yeah, 100. Okay. So also there are also no SDN control policies, as if I do this GET request, it shows the 5 default flows with no rules. Essentially. Okay. So if I go and close everything, go into this and then change the bandwidth. The video will probably still play at 2400, but I can, let me actually do that. Change it to 2. I do H4, Epiphany. One. Yeah, you can see that the video jumped from 2400 bitrate down to 1200, which then loads the video. Yeah, and then if I show that for the low scenario with the 1 bandwidth, I can see that it will drop down to 300. Well, it should anyway. Yeah, you can see that it drops from 2400 down to 1200 down to 300 based on that link. Now I'm going to show the control policy working. So let's firstly reset the instance. So I have the flows already set up. So this is flow 1 for prioritizing IoT traffic. This prioritizes UDP packet information coming from 880 and sets it to a priority of 100, where this does the video, which sets to a lower priority of 50. If I execute these put requests, 201 created, and then open up MOBA again, and then let's just do that, so that it's actually running H4. If I do a GET request, it will show the 2 rules inside of the REST API, which you can see here. So that's ID 1 and that's ID 2 based on the priority. However, if I do another GET request, you can see that no packets go into this just yet. But the moment I start the browser, sorry, when I start the browser, you'll see that the values for the second flow rule, which is here, will start to increase. So it went from packet count of 0 up to 1,000, where ID1 still didn't have any packets. But then when I stop the video and xterm h2, h3, and host a UDP server on host 3, port 8080, then reference that host UP880 B5M-T60, which sends 5 megabits of UDP traffic to the UDP server on host 3 for 60 seconds. Where the moment I start doing this and then do another GET request, you can see the packets actually increasing for that node, or for that flow, sorry, showing that traffic is actually getting directed to that. Then I'll just go through an example scenario just to show what I repeated for each of the 3, which included 5, go there, run it, H2, H3. So I would firstly start the video, and then run the commands that I just ran. So hosting this and hosting that, sending the traffic to host 3, and then proceed to run the video. Should load. The moment it loads, I will then observe to show that it maintains a proper bandwidth. But the moment I start introducing UDP traffic, you'll probably see the buffer level dropping. Yep, as you can see there. From this, I'm also looking for visual degradation, so in terms of like visual pixelization, as well as seeing the buffer, and then I can look inside of this to see that's the packets increasing, showing the flows are working as intended. Where, sorry, well, the moment that this stops running and the video will start playing. Okay. Thank you very much for listening.